In this problem, we're asked to do a sketch of this rational function with these given characteristics. So let's first just talk about what each of these characteristics mean. So because we have a domain restriction, the domain cannot be positive 2 or positive 5. These are normally talking about where we're going to have vertical asymptotes. Okay, they are values that we cannot plug into your original function because it will give you a 0 in the denominator. Okay, so this next one says the limit as x approaches 5 does not exist, which is definitely going to be a vertical asymptote. Okay, which means that 2 is probably something special going on at 2, since 2 does not actually occur over here. Okay, so something special is going to happen at 2, but 5 is definitely going to be a vertical asymptote. So let's go ahead and put those in here. Here's your vertical asymptote through 5, and then probably something special happening at 2. That's 1. Here's 2. So let me erase this one mess up here. Okay, so we have restrictions, positive 1 and or rather 2 and 5 are not in your domain, so we have asymptotes there. Okay, these next little sections are telling you what is the graph doing as x approaches 5 from the left. Okay, so here is your asymptote. We're talking about the graph as it moves from left to right towards the number 5. So when it says that as x goes towards 5 from the left, it goes to negative infinity. So that means that the graph is going to go down here at this asymptote. And this says as x approaches it from the right of positive 5. So we're talking about moving from off the screen this way towards the graph. It's also going to negative infinity. So both of these graphs are going to be going down here towards this asymptote. Okay? If one said positive infinity, then it would be up here, and they would be going in opposite directions. One would be going down, and one would be going up. Okay? So over here, the limit as x approaches the number 2 is positive 3. Okay? So notice now we have what happens when x equals 2. Well, the graph is at 3, but because x can't be 2, that means this is where a hole or a removable discontinuity is going to happen. Okay, so rather than having a nice, smooth, even graph, now we have something that has a hole in it. Okay, so we have a vertical asymptote at 5, and at 2 is not included, so we have a hole at this y value at the point 2, 3. And the last one is this one, as the limit as x approaches positive and negative infinity. This is talking about your horizontal asymptotes. Okay, so we have a horizontal asymptote at positive 4. Anytime x approaches positive and negative infinity, you are talking about your horizontal asymptote. What's happening for very large and very small values to the left and right of your graph. Okay, so to finish it off, we have the x-intercepts when y is 0. So we have an x-intercept at 4 and at 6. And they both cross. That's what our multiplicity of 1 means. And we have a y-intercept at positive 3.5. Okay, so from all your characteristics, we can put in all of these little road maps here so that we can finally make a good sketch of your graph. So it has to be close to the asymptote on the left, go through the point 3.5-ish here, go through your hole, go through your x-intercept, and go down to negative infinity. And then the other one has to come from off the screen on the right, go through positive 6, and also go down towards negative infinity. Okay, so you're not asked to write an equation for this, but this would be what the graph would look like, a sketch given all of these characteristics.